So we will try to discuss something about the cluster sizing, how you decide the size of the cluster, and the hardware. Then we talk about something called performance tuning. This is one of the responsibility of a Hadoop administrator. I don't know what the concepts that we have discussed in the last couple of sessions, how you have understood or how you are receiving those things, I'm not sure. But if you observe closely, we have discussed about the big data, and then we connected to Hadoop, then we connected to, because Hadoop implicitly means HDFS and MapReduce. That is the reason we discussed about file system, distributed file system, and then Hadoop distributed file system, and discussed briefly about the MapReduce part, that is using your massive parallel processing technique, how your MPP, your massive parallel processing, is going to help in processing your huge volume, wide varieties of data. And then we discussed about components of Hadoop ecosystem. And then we discussed something related to the Linux file system. The reason why all these been discussed, this forms the base or the foundation to all our coming day learning aspects. And I also mentioned something about fuse. I don't know whether you have gone through this as part of your learning process or not. Fuse, that is file system in user space. All these forms to be the base for your coming days aspects. Without having the knowledge on these things, understanding certain aspects is going to be tough. That is the reason why all these been discussed. Now, as part of that, now we are trying to discuss something about cluster sizing and the type of the hardware that you choose for your cluster. How basically you decide? As an admin, how you decide that this is the size of the cluster or this should be the size of the cluster? Any idea? Any idea, friends? In terms of the size, we are talking about CPU, memory, and a network. And more specifically, your storage. This is a more specific thing. CPU for the sake of your computing, memory for the sake of provisioning your processing directly or indirectly, network for the sake of performance in terms of transferring the data. This is purely hardware. Of course, here we have a lot of choice. Here we have a lot of choice because Hadoop is basically meant to have all these things happen against your commodity hardware. So we don't have any problem towards that. Any idea towards cluster sizing, friends? Cluster sizing. How you
No,
decide
Srinivas.
the cluster sizing? I mean, basing on
Based on the
what? Yeah,
data,
yeah, that's
and
good.
its
Yeah,
and number of users who's going to access that data.
okay. One is you're saying that the amount of the data that you're saying.
Yes, Srinivas.
The time on refreshing the data.
I think there is a lot of background noise. Yeah. How you decide the size of the cluster and the type of the hardware? Yeah, not an issue. You look at this one, the types of roles you have in any Hadoop cluster. What are the types of roles you have in any type of Hadoop cluster? The basic roles I'm talking. Apart from this, we have other roles also. Name node, job tracker, task tracker, and data node. If you look at the basic hardware configuration that is required for your data node and the task tracker, 12 to 24, 1 to 4 TB hard disk and just bunch of disk configuration. We don't need any RAID. We don't need any RAID. So I think you understand what I mean by we don't need anything in the RAID. Why we don't need anything in the RAID? Just bunch of disks. That is what we call it as JBOD. Just bunch of disks configuration. 2 quad or hex or octa-core CPUs running at least 2 to 2.5 gigahertz. 64 to 512 GB of RAM. Make sure friends here, 64 to 512 GB of RAM. Gigabit Ethernet or 10 gigabit Ethernet. The more storage density, the higher network throughput is needed. Now looking at this one, you understand the core hardware configuration. The core hardware configuration. And you also see For name node job tracker and even the standby name node, that is your secondary name node, you can see here you can see the configuration here. And you also need to understand one point here. The name node will also require RAM directly proportional to the number of data blocks in the cluster. How you decide the RAM to your name node? The RAM to your name node is a good rule of thumb is to assume 1 GB of name node memory for every 1 million blocks stored in the distributed file system. Hope you understand what the point that have been mentioned very clearly here. What is this? A good rule of thumb is to assume 1 GB of name node memory for every 1 million blocks stored in the distributed file system. In what way this is going to influence, friends? In what way this is going to influence? 1 GB of name node memory is required for every 1 million blocks stored in the distributed file system. You need to be active in the session, then only it will make more interactive. If it is a one-sided, I will not come to know what exactly you are looking at.
I'm just thinking, I have no idea. That's the reason I didn't respond, Srinivas.
No, I understand. Because your name node is considered to be, the single point of failure, which I have already mentioned some time back. You remember, name node is considered to be SPOF, single point of failure. If name node is down, the entire cluster becomes inaccessible. Single point of failure is what we say. For any reason, if the name node is down, the entire cluster becomes inaccessible. Which means, even if you submit the job to the job tracker, job you have submitted to the job tracker, even then.
So Srinivas, one question, Srinivas.
Yeah.
So, I mean, initially you said, yeah, name node is single point of failure, but later on you said yarn is there, so we need not worry and
No,
we
not
can
yarn.
no more.
Not yarn. It is zookeeper to make the high availability.
Yeah, so I mean, so the cluster sizing what we are discussing is with related to Hadoop 1.0 or it is related to Hadoop 2.0?
Is 2.0 only. Is related,
Okay.
is in the context of 2.0 only. But why we are again bringing this job tracker and all into picture is to understand the aspects clearly. Then only we will be able to understand the resource manager and the other stuff. That also we'll be discussing in the today's class itself. In the place of this job tracker, we may come across something called resource manager. A resource manager. Let it be job tracker or resource manager. When you submit the job, it actually communicates with the name node internally. For what purpose? When we are submitting the job to the cluster, we are also going to specify what is the input path. Input path. Input path, I mean, this is how you do it actually. Hadoop zar, and you specify the zar file myjobs.zar, and we specify what is the job you want to run, and then we specify /tmp /sandbox /abc.txt /tmp /sandbox /abc_out. So when my intention is to run a jar file, I need to tell where that jar file is located. Inside this jar file, there could be number of jobs. I need to tell which job to be executed. And when my job is getting executed, from where I should read the input data, that I should specify. This is called input path. When the job is getting executed, where the output needs to be written, that also I need to specify. That is called your output path. This is how you make your job to run. So when you submit the job to the job tracker, it is going to ask the name node. The client has submitted the job to me to process some data set. Please tell me the blocks where the abc.txt resides on the cluster. Job tracker is going to ask the name node saying, I want to process the file called abc.txt or a directory called xyz, whatever it is. Please give me the list of the blocks belongs to that path, because job tracker or resource manager doesn't know where the blocks are located. That is known only to the name node. If name node is down here, even job tracker not able to function or resource manager not able to function. So that is the reason why we are calling this as a single point of failure. And slowly this has been eliminated to make your cluster to be highly available. Of course, today we don't have that threat. We don't have that threat. What is that threat? Single point of failure threat. With the advent of Zookeeper, journal nodes and all that stuff, we don't have any threat of single point of failure. Lot of alternatives been developed. But still, for any reason, if the file system image, that is what we call it to be FS image, maintained by the name node, if this becomes unavailable, again the cluster becomes unavailable. So still at the, even there is a 0.0001% chance, if the name node is unavailable, the cluster is unavailable. That single point of failure is still confined to the name node only. If a job tracker is not available or resource manager is not available, still the cluster is accessible. Only your processing may get affected, but if your name node associated data is not available, then your cluster is unavailable to work in any mode. The reason why we are discussing all these things, when name node is maintaining the metadata, I mean the information about blocks, when it is maintaining the information about the blocks stored on the cluster, we should have a metric for that. A good rule of thumb is to assume 1 GB of name node memory for every 1 million blocks stored in the distributed file system. Based on that, we need to make sure. How we decide the size of the I mean the memory of the name node, the RAM of the name node is based on that one. Are you able to understand this one now?
Yes, Srinivas. So one question, I mean, while sizing the cluster, do we need to consider secondary node or no? Because it is not mentioned here, right? So we
No,
don't need to consider secondary node?
no, we definitely need to consider secondary name node, because secondary name node, whatever we are working with the name node, almost the secondary name node also need to have the similar configuration. Similar configuration. Secondary name node also need to have the similar configuration. The only thing
Okay.
is, in the absence of name node, it will not automatically come into picture. But rest of all, it is going to be the same. So we need a secondary name node also to be of similar in terms of the processing ability, I mean the CPU, RAM, in terms of the hard disk, everything. It is
Okay.
needed at the same level. So we have two things there, of course. It's not related to the administration, but still need to have the understanding. We have two things. One is FS image, what I mentioned. That is the static storage. Static storage. And we have one more thing called edits log. This is what the delta, the changes that are happening to your file system. Change to the file system is actually being tracked inside your edit log file, and over a period of time this edit log file will get merged to your file system image. This edit logs file, how it is being maintained on your name node, exactly the same also on your secondary name node. On the secondary name node also we'll be having a file system image, and we'll be having this edits log. There also you'll be having both. In the pseudo cluster, as all will be on the same, we don't have the option. But in a fully distributed mode, these two needs to be on separate machines, and it is recommended that we make use of enterprise class for masters. For masters, we need to make use of enterprise class hardware. For slaves, we can go with any commodity hardware. Masters, I mean your name node, secondary name node, and your job tracker or resource manager. Then your H master, I mean H base master. So for all these things, you need enterprise class hardware. When it comes to the slaves, like your data node and task tracker, and we also has got something called region servers when it comes to HBase. So commodity hardware works fine with the sleeves. That's not a problem. So as name node is the one which is going to give the details about the files and the associated blocks and their replicas. So for every 1 million blocks stored in the distributed file system, we require 1 GB of name node memory. Accordingly, we need to upgrade your name node time to time. The same name node cannot be forever. You can see this here. Light processing configuration, 2 hex core CPUs, 24 to 64 GB memory, and 8 disk drives of 1 TB or 2 TB. This is for your light processing configuration. Light processing configuration. For the balanced compute configuration, they have specified 48 to 128 GB memory, 12 to 16 disks of 1 to 2 TB size. For storage heavy configuration, what needs to be done? For compute intensive configuration, what needs to be done? They have mentioned. So, before you decide to set up your cluster, we need to take all these parameters into consideration. Not only this one, you see here the table that is being shown. With this, you are able to understand. Look at that table, study that table. If the average ingestion rate of the data into your cluster is 1 TB and the replication factor is 3, then the daily raw consumption is 3 TB data. Are you following with me, friends, what I'm trying to share with you here?
Yes, yeah.
So how you decide all those things is based on the amount of data that is going to come into your cluster every day. Based on that only we decide. It is not bluntly that we go with some, we put some rough figure and accordingly we take it forward. No. If you look at that one, definitely you need to get some queries. MapReduce temp space reserve. In what way? See, you may get frustrated every time. Why we are moving to a bit of development and coming back to administration, bit of development and coming back to administration every time. That is where I mentioned in the beginning. Percentage wise, I'm not sure how much percentage exactly. But even if you are a Hadoop admin, it is 60 to 70% admin and 30 to 40% dev. Maybe this percentage slightly up and this percentage may be slightly down, whatever. But there is no such thing called a true admin. I don't look at all. That is the reason why in the today's discussion we are about to talk how you run a MapReduce job. As an admin, you may not be running a MapReduce job at all. But why we need to run a MapReduce job? We need to run a MapReduce job and understand its life cycle because performance tuning is a responsibility of the Hadoop admin. Performance tuning is the responsibility of the Hadoop admin. When performance is the responsibility of the Hadoop admin, we need to understand when a job is running on the cluster, what is its life cycle, where tuning things are expected, and how those tuning things are going to improve the efficiency. Nee, we are not able to hear you, Nee. Nee, we are not able to hear you for some reason. You mentioned something. You haven't understood the math. Okay, can you please tell me what is that your query? Okay. We'll definitely look into that. We'll go back to that. See, if the average daily ingestion rate, what do you mean by the ingestion rate? The amount of the data coming into your cluster. If it is 1 TB and the replication factor is 3, I have already mentioned, I have shown it to you, how you decide the replication factor and the block size. You're going to decide those things on the cluster. Let me show you that even.
So Srinivas, one question. So
Yeah.
based on, I mean, initially we decided this is the size of cluster, and we started proceeding, and later on in future if we feel like it is still low and we want to increase it more, so is it upscaling is easy, or it has to be reconfigured, like how that will work?
Now, when it comes to the name node and those things, we need to have the projection in advance. Data nodes and all, leave it, we can do any point of time. But that is where we need to have that understanding. Why these things are coming into picture is for that reason only. Which are coming into picture, your daily ingestion rate and all, we need to have that understanding. Without those metrics, if you plan the cluster, then resizing is demanded frequently, and that makes your cluster not to be available all the times. More than that, there is no threat. And of course, this cluster is not going to be used by hundreds thousands of people across the organization, so not been much impacted. If the cluster is not available for a day or two, say with some plan in the mind, you set up the cluster, and your needs got increased abnormally for whatever the reason, then you may down the cluster and increase your hardware abilities and all, and then you can restart your cluster and take it forward. That's not a problem. Say, if I understood your query correctly, if the name node memory is assume 64 GB, and if it is demanding 128 GB, so if upgrade is possible on that, we down the cluster and make it to be 128 GB so that it can be continued smooth. Is that your question, Sunil?
Yeah, Srinivas, yeah, that makes sense. Yes.
Yes, that is there, because it is not like your
So it is.
transactional server, or it is not like your server which where your business is running, so it will not be impacted much. It will not be impacted much.
Okay.
I
Yeah,
think,
that's what I wanted to know.
yeah, it will not be impacted much, because your cluster need not be available, because as it has got a specific purpose. Let me show you. I don't know. Oh, 1 second. Look at this one. Randomly, we are not specifically targeting anything here. See here, someone using this, someone using Hadoop cluster, Benipal Technologies. We really don't know what what they do and all, what is the company and all. But who are all using Hadoop cluster? That is what Hadoop powered by, if you see, they have a 35 node cluster. Maybe currently it might be more or less, but just to make you to understand. We have been running our cluster with no downtime for over 2.5 years and have successfully handled over 75 million files on a 64 GB name node with 50 TB cluster storage. We are heavy MapReduce and Apache HBase users, and use Apache Hadoop with Apache HBase for semi-supervised machine learning, artificial intelligence, R&D, image processing and analysis, and Apache Lucene index sharding using Kafka. They mentioned wrong, Katta, that is Kafka actually. So you see the other one, 14 node cluster. Each node has two dual core CPUs, 2 TB storage, 8 GB RAM. We use Apache Hadoop for matching dating profiles. Hope you are following here what I'm saying. Billing Brillig is a company. Our primary cluster is 10 nodes. Each member has 2 into 4 cores, 24 GB RAM, 6 into 1 TB SATA drives. So I think you understand from this one. There is no comparison in terms of the hardware and in terms of the size. You see the same thing if you go to a Facebook, it also should be, yes, it's there. Currently we have two major clusters. A 1100 machine cluster, I think this information is old information. Today we have more. A 1100 machine cluster with 8800 cores and about 12 petabytes raw storage. And a 300 machine cluster with 2400 cores and about 3 petabyte raw storage. Each node, the commodity node, not the master, has 8 cores and 12 TB of storage. So you understand from this one what usually, it all depends how they are able to decide all these things. It is all based on the amount of data coming into your box every day. That is a benchmark here. Based on that only we decide. You look at this one. If 1 TB of data is coming into your box every day and a replication factor of 3, so daily raw consumption is 3 TB. That is the daily ingestion into replication. So if the node raw storage is 24 TB, how 24 TB? 24 TB will not be as one hard drive. Each hard drive of 2 TB capacity, that is 2 TB SATA 2 HDD into 12, that is 24 TB. Out of which the MapReduce temp space reserve. Now tell me, as an admin, how you understand this MapReduce temp space reserve, where we need to keep 25% aside.
So normally if any program runs in Windows or Linux, it needs some temp space to store the processing files, and once the process is completed, it will empty that. So I think for processing, we need the temp space.
Absolutely. For processing, we need temp space for the reason, I mean, may not be exactly 100% right, but it is the concept only in the context of MapReduce, because your MapReduce job execution happens in phases. It will not happen in one phase. It will happen in multiple phases. When the MapReduce job execution happen in multiple phases, we need to have the provision to store the intermediate data till the job is going to complete the execution. Once the job is going to complete the execution, then we throw that out. But till then, it needs to be stored somewhere. To make that possible, 25% of the storage is dedicated towards the temp as a MapReduce temp space reserve. Apart from this one, of course, that is very minimal. You also need to reserve some space for your operating system, because this setup you are doing it on, where you are doing it, you are doing on a machine. This is a bare metal box. On a bare metal box, we are going to set up a CentOS and then assign an IP to that one and make this to be keyless entry, that is SSH enabled. So on this node or on this machine, we can set up or we can bring this node into cluster. That is what we have discussed before. On a bare metal box, install the CentOS, assign an IP to that one, and make it SSH, so that we can bring that as a part of the cluster and start using it. Now, CentOS, where it has been installed? On HDD only, right? So that may be small, around 6 to 10 GB, because we don't need any UI features and all. We only need that is the reason why I discussed about the file system. I don't know how you received it. So all these are the ingredients. If you want to make a good dish, if you want to make a good dish, it is always advisable that you keep all the ingredients available and accessible to you, then only you can make a dish. You may have a great intention of making a good dish, but every frequent you are getting disturbed and going here and there to get the ingredients. Your focus on making a right dish will never happen. That is the reason why we are arranging all the necessary ingredients to make sure we get a right dish. So for CentOS also I need to reserve some space. But that is very minimal. But that also need to be taken into consideration. So keeping all these things, this metric has been shown here, 25% of the storage for intermediate MapReduce data. So what is the net node usable raw storage? Out of 24 TB on the node, if 25% is been kept aside for your MapReduce temp space reserve, what is the net?
So maybe it is for system files, something like that.
No. That is all, the 25 only will be sufficient. So 25% of the, say, your node capacity is 24 now, 24 TB. How 24 TB came? 2 TB hard drives, 12 in number, gives each node 24 TB. Out of which 25% is reserved for your MapReduce temp space for storing your intermediate data. That is what been mentioned here. For intermediate MapReduce data, that I'll be showing it to you practically now. So out of 24 TB, if 25% is reserved, that is 1/4 is reserved, 6 TB is gone. So what is the net usable raw storage in terms of the node?
18 GB.
18
18
TB.
GB, yeah.
18 TB, right?
Yeah.
So 1 year flat growth. 1 year flat growth. How much it comes? At an average of 1 TB. So 1 year, how many? You will have 365 TB required.
Yeah.
You agree with my point?
It should be into 3, right? Like 365 into 3, right?
Yeah, 365 into 3, sure. Now we are talking about 1 TB at the average daily ingestion rate of 1 TB. So you require 365 TB alone for your storage. So alone for your storage. And when it comes to the replication of 3, we require 3 times of that one. So if 18 TB on each node, how many nodes we require in a year? How many nodes we require, friends?
365 into 18?
365 into 18. Why you require 365 into 18?
Just calculated based on 1 TB per day.
Yeah. No, that is where I think yeah. What is the daily consumption? 3 TB only, right? Not 18 TB. So 18 TB is my node capacity. I mean usable node capacity. So how many days data can be stored in one node at a daily consumption rate of 1 TB and 3 TB raw storage we need? 6 days, right?
Yeah, 6. Yep.
So each day we require a 3 TB storage space on the cluster. So 18 GB, 18 TB, it is sufficient for 6 days. Every 6 days I need one node. So in a year, if I take that projection into consideration, in a year I need 61 nodes.
Yes, yes, 61 nodes, yeah.
That is what is been mentioned here, the math. At a 5% growth per month, if the data is going to grow, because it is not exactly 1 TB every day, right? You know very well data needs are going to grow tremendously time to time. If I keep a 5% growth per month in terms of my ingestion rate, I may need 81 nodes. If 10% growth in terms of data ingestion, then I may need 109 nodes. Now I think you are able to understand how come this calculation is being done. This is all in terms of number of nodes on your cluster.
Srini, can you, oh, sorry, can you come back again on the node raw storage and node usable raw storage? I'm just confused with that part.
No. Absolutely, I'll do that. So if you are able to ask me questions like this, I don't mind and I don't hesitate to share anything, but I need to know what exactly you are looking at. Then only I'll be able to address your needs. So imagine if it is 1 TB ingestion into my cluster per day. This 1 TB is the actual data that you are gathering. The actual data that you are gathering. This 1 TB is the actual data you are gathering and bringing into your Hadoop cluster every day. You know very well, your Hadoop cluster has got your Hadoop cluster. Let me take you there. Has got a replication factor to make your data highly available. For data high availability, we have replication factor. You go to your configuration in terms of HDFS. What is HDFS block size? It is 128 MB that is configured here. 128 MB. These are the compression codecs that are possible. And this is my data node data directory. I'll be showing these things, journal nodes and all. Name node data directories. Name node data directories. Name node edit directories. If you want, you can specifically configure that one. Same like you are also going to see the replication factor. On a pseudo cluster, this cannot be set more than 1 and it doesn't make any sense. On a pseudo cluster, you will not have your replication factor more than 1. But on a fully distributed mode, this is always in the control of the administrator. Depending upon your need, you can make, but by default on a fully distributed mode, the cluster On a fully distributed mode, the cluster no, replication factor is kept to be 3. Now, taking that into consideration, if I am ingesting 1 TB of data, I actually need 1 TB of storage. But being the replication factor 3, I need 3 TB of storage per day. You agree with my point?
Yeah.
So hope you understand this one. Let me see replication. It is taking time to give that all the configuration details here. So like how you have seen there, data node, failover, general node, name node, ports and addresses, replication, yes. Because you have more properties here, it is taking time to actually load that. That's not an issue. It's not been available here. If you look into this configuration file, you'll be seeing the default replication factor for this one. Yes. See the property here? DFS.replication is set to be 1 here. Because this being a pseudo cluster, this number can be configured by you either to 2 or 3 or even 4, even 5. The more you configure the replication factor, the less the storage you'll be able to use it. That is available in terms of the node. So keeping that factor into consideration, if I have my 1 TB ingestion per day at a replication factor of 3, so each day how much storage I need? 3 TB per day I need. This is the raw storage. Of course, friends, there is a how you can make this to be more efficient. There is a way. I'm going to talk about that one. So if I have my node configuration like this, 12 into 2 TB SATA hard drive. If this is what my node storage capability, each hard drive is of 2 TB size, and we have 12 such hard drives in terms of the node. So what is the node capacity now? 24 TB is the node capacity. But will you be able to use the entire 25 TB for your storage? No. For the reason, out of this 24 TB, 25% I need to keep aside for my MapReduce temporary storage or intermediate storage. Out of 24 TB, if 25% is dedicated for that one, I have only 18 TB left over. In one node, I can use only 18 TB storage, though its storage capacity is 24 TB. I hope you got the point now very clearly. Now in this 18 TB, how much data I can store? I can store the data equivalent to 6 days. 6 days data I can store in 18 TB. Because each day 3 TB including your replication at the rate of 1 TB per day ingestion into your Hadoop cluster. Every 6 days I need one node. Every 6 days I need one node. Then for 365 days, how many I need? 61
61.
nodes. 61 nodes I need. This is at the rate of 1 TB ingestion per day. Suppose if this 1 TB is going to be 5% more, it is getting increased every month, assume. If the data ingestion, instead of 30 TB per month, it is assume 31.5 TB. Are you getting my point? At the rate of 5% increase in the data ingestion, if my data ingestion rate is going up 5%, then I need, how many nodes I need? I need 81 nodes. If my data ingestion rate is growing 10% per month, then I need 109 nodes. Now this is how I am going to project my needs, how my data is going to grow. Based on that, I am going to decide what should be the configuration of my cluster. Maybe over a period of time, what happens? My hardware configuration also gets increased. It is not, today we have set up a node with 12 into 2 TB SATA hard drives. Over a period of time, if you are getting 4 TB hard drives at a much cheaper price, then I can go with 12 into 4 TB, then each node is going to have 48 TB storage capacity. It is not necessary the hardware needs to be homogeneous. This is one point what I want to bring it to your notice clearly, friends. What do you mean by homogeneous? So with what hardware configuration we initiated the cluster, we need not maintain the same throughout. As and when the things increases, you have the comfort to increase even your. Are you comfortable understanding this one, friends?
Yeah, Srini, yeah.
So this is how you are going to decide. And usually, depending, because you know very well, here if you look at the concept, for what purpose we use Hadoop for storing logs, news analysis and tag analysis. That is what Follow News organization is using Hadoop. Now, when you are planning for Hadoop, you will come to know very clearly, right? You also see here, explore to yellow pages. We use Apache Hadoop for our internal search, filtering and indexing. Each elastic cluster with 5 to 80 nodes. That is what they are using. Or tell me, friends, with this basic description what I have given for these companies, can't I able to estimate whether my processing is going to be light processing or balanced compute configuration, storage heavy configuration or compute intensive configuration? Can't I decide into which category my cluster fits in? I mean, basically, what is the purpose of setting up your cluster? Is it for storage purpose or it is for computing purpose? Computing purpose, I mean processing purpose. Or it is for both. You will have an idea, right? Are you getting my point, friends?
Yeah, yes, Srini, I have a small doubt. Like, I'm not sure whether this is a valid question.
No.
Just want to ask.
Go ahead.
But you said like the node configuration, like for example, if I'm changing it to 12 into 4 TB, my node, it is going to be coming down from 61 to 30.
No. You are not going to change the existing because you have kept the maximum allowable storage to your hardware that is available that time.
Yeah.
See, your motherboard, when you are setting up, usually what extent your motherboard is going to support, your server board is going to support, to that extent you are going to fill. Now you started using the cluster, 1 year passed, 2 years passed. Now your new hardware, the enhancement in the hardware has made the hard drives to be built with 4 TB capacity. And your server board also able to support 48 TB storage. Then you can bring those new nodes into cluster. That is what I mean to say, not changing the existing one, because existing one when you're planning, you are going to plan for the maximum, right?
Yeah. Okay. That was my doubt. Like that. Okay. Yeah. I got it now.
So that is what I mean by your cluster hardware need not be homogeneous. I mean, so today you started you're setting up your cluster with some configuration of the nodes. We need not continue the same. As and when your hardware is getting enriched and it is becoming cheap, you can go for the higher hardware, right? So those nodes also can be part of the same cluster. We need not worry for that one. That is what I am trying to share with you. Now, so this is how you are going to decide the size of the cluster based on your, I've given rough estimates here. So tomorrow when you go to the environment, of course, by the time you go there, they might have already decided, but I'm seeing there are many occasions where after the resources are being taken and then I mean, probably you may be the first resource to that company to work on Hadoop. If that is the case, then sizing also needs to be decided by you only. Sizing also needs to be decided by you only. Hope you are getting my point, friends. So that time how you decide, you need to take all these metrics from the client or where you are working, you need to get all these details. What is your daily ingestion rate? And based on your, what is your projection growth every month or every 2 weeks? Will there be any change in terms of the data that is coming into your box? If so, what is the percentage of that growth? All those factors you take into consideration and you keep the room for next 1 year or 1.5 years, whatever, based on the budget available there and their projection and their usage and their need. Need, I mean, I may be interested to set up the Hadoop cluster only to evaluate certain things. If I am okay, then I want to go ahead with a real cluster. The various needs. Based on that, I need to decide what should be the right size. And based on that only, once this is decided, then only I will be able to decide about my masters. See, I will not decide my master and then I think about the data nodes. I will not be doing that one. I decide my masters based on my next 6 months or 1 year projection. I decide, oh, so these many blocks will be there. When you know very well 1 TB of storage and my block size is 128 MB. So you come to know, right, how many millions of blocks you'll be having over a period of time. And I've already given you the calculation for every 1 million blocks. What is the RAM that is needed to your master? Based on that only you are going to decide today what should be the configuration of your master. It makes sense, friends?
Yeah.
That is the reason why we are talking about the data storage. And after this has been decided, I need to decide. See, this is all about my storage. But what is the purpose of your Hadoop cluster? Your Hadoop cluster is meant only for storage? Absolutely no. Your Hadoop cluster is meant for your processing also. When your Hadoop cluster is meant for processing, I need to now bring these into consideration. What is the core need of your Hadoop cluster? Is it for light processing? I've already mentioned it to you by showing you this one. Each company has got their own need. Our Apache Hadoop environment produces the original database for fast access from our web application. We also use Hadoop to analyze the similarities of users' behavior. Now I come to know, right, what is my need? What is my need? I come to know very clearly. Based on that only, I am going to decide. I'll show you certain examples here. They have currently 3 nodes only. You see this company, they have only currently 3 nodes. We have only 3 nodes. Still they are having a Hadoop cluster. Yeah. See this one? Each night we run 112 Hadoop jobs. Each night we run 112 Hadoop jobs. So we come to know, right, what is my need? So I need to take all these parameters into consideration before I decide into which of these 4 my cluster belongs. Whether it is for compute intensive or storage intensive or balanced compute or light processing. Based on that only, I am going to decide how I need to go with my cluster configuration. It makes sense, friends? See, storage is one side of the coin. See, at what rate you are getting your data into your box, based on that you are going to decide the node configuration and how many nodes required in a year, and based on that you decide what is the name node, what is the secondary name node, your resource manager and all this stuff. And in order to decide those things, we need to have into which of these categories your cluster belongs. Based on that, we are going to decide what hardware configuration is required now. Hardware configuration in the sense your CPU capacity and your network, your Ethernet cards and all that stuff you decide based on the type of the cluster you are going to set up. Is it light processing cluster or a balanced compute configuration? I mean, both for storage, and you are going to equally use for both storage and computing, and storage heavy configuration, because my core goal is only to offload my data storage. I also do the processing, but my core need is the storage. Compute intensive configuration. So like that you see here. Based on that only this is been. And don't fix up your mind, friends. If depending on the budget of the organization, we can also make this hardware configuration to go a bit higher. It is not that we need to go only with this one, because company may have a sufficient budget to go for a better node configuration, so that it can accommodate, right, in the coming days based on your future needs also we can. But certain times what happens, I may be interested only to evaluate the ability of a Hadoop cluster. Based on that I want to decide and take it forward. When you want to set up a 5 node or a 10 node cluster to do my POC, and then based on that I decide, then I may be going with a different configuration. So hope you are understood with all these things what exactly I mean by the cluster sizing, both in terms of number of nodes and the configuration of each node and the configuration of your masters. Make sense, friends? Anyhow, I'm going to share these things, these documents with you, so that you can do further R&D.
Yes, Srinivas.
I have also given one use case also here, so that you will be able to understand how the replication factor and the testing part and the backup and the disaster recovery, how it can be. You see this one very closely, friends, here. This is also one of the important aspects that needs to be considered. I don't know whether you experience this anytime or not. When your hard drive starts filling up, now you see here, what is my C is 145 GB free and my D is almost 89.1 GB free. You see how your system is going to respond at this storage availability. Slowly, over a period of time, next 2 months, 3 months, 4 months, 6 months, 1 year, keep going. My D starts getting filled up, only 10 GB free. My C also starts filled up, only 15-20 GB free. Because I install more and more applications and do various things on my machine. When this starts coming down, the responsive time from your system starts coming down. Did you ever notice that? Did you ever notice that?
Yes, Srinivas. Yes.
So same is applicable even to this one. As with your personal computer, when the main hard disk drive fills with space, the system slows down considerably. Hadoop is no exception. A hard drive performs better when it's less than 85 to 90% full. With this information in the mind, if the performance is important to you, you should bump up this swap space factor from 25 to
33%. 33%.
Then you're here, you have mentioned it to be, what is that you mentioned here? 25%, right? So that I need to lower it to 33, so that much more storage I'll be losing here. Why I need to consider that factor? I need to consider that factor if performance is important for you. See, it may look very funny here at this stage, but 8% we are losing in terms of the storage on every node. At the cluster level of 50 node, 100 node, how much storage difference comes, you can imagine, friends. Even 1-2% at a huge scale makes a lot of difference. 1-2%. Maybe when it is a small, maybe 1 TB, in that 1 or 2 GB, if it is gone waste, we don't care. But when you are going to higher volumes, 1 or 2% also makes more. We need to be very careful in that. So that is the reason why I raise this point very clearly here. You need to also take this into consideration. Based on this only, you are going to decide whether this 25% needs to be made 33 or 28 or 29 or 30. You decide based on that one. Hope this makes more sense for you, friends, to understand how your sizing and your future needs and your volume of the data that you are going to store decides your cluster size and the configuration. And above all these things, depending on the budget of the organization, also you are going to decide the type of the hardware that you are going to procure to set up your Hadoop cluster. You may not be going with very expensive. So take all these factors into consideration. We finally summarize. Budget one side of the coin, the other things the other side of the coin, and we map all these things and finally decide. We go with a cluster of 10 nodes at this stage, and over a period of time this gets added with 2 more nodes. We need not worry for that one, because I have already mentioned it to you very clearly that anytime you need to add more nodes to your cluster, it is just going to your host and go over there and click on add new host to the cluster. Yes, you are done. You need not worry for that one, friends. At any point of time, you can add new host to the cluster. You also can decommission the existing. Of course, here you have only one. There is no concept that you are going to decommission this host. You see that one here, the factor you can see. Yeah. You can stop the roles. You can make this to get decommissioned. And after you decommission, you can take out that from your cluster. You can remove from the cluster after it is been decommissioned. So you can remove from, you can stop the roles on this one, whatever the roles you want, you can stop on this host. All will be in your control once you bring that host into your cluster. And that can be taken out from your cluster after you decommission that. You can take out that node. It works as a normal independent CentOS. I already mentioned it to you very clearly, friends. Your HDFS, I mean your distributed file system, is being set up in the user space, not at the kernel level. So when you take out the, even after the configuration is deployed onto that machine, still if you take out that machine from the cluster, it works as a normal plain CentOS box. And you will not come to know that sometime back there is a DFS that is being set up here. You will not come to know that at all. The DFS is recognizable. I mean that Hadoop distributed file system is recognizable only to your cluster, not to your regular file system commands, because that is being set up in the user space as a layer. And on the top of that fuse only, this Hadoop distributed file system is being set up. So it is something like the water drop on a lotus leaf. So it will get spread on the lotus leaf. Once the drops falls down, you will not even find the trace of that water drop on that leaf. Same is the thing here. Once the node is being taken out from the cluster, it works exactly like your CentOS box, and you will not even come to know that distributed file system is being set up on this one sometime back, because that is all at the user space, not at the kernel level. I have already mentioned that one, and I have asked you to go through fuse. I don't know whether you have gone through that or not, but if you have gone through, you will come to know the beauty part of your fuse. And that is the reason why on a bare metal box you are just configuring. What is that we are doing? Setting up your, you are just setting up your CentOS and assigning an IP to that one, making it a passwordless entry. You are bringing the cluster into the, you are bringing the node into the cluster and deploying the configuration required, and to make the storage space expanded. Once the storage space expanded to that node, your name node starts filling that one with the blocks and make it balanced, the cluster balanced. And the moment you decommission that one and take out that node from that one, the blocks that are supposed to be on that node are being uniformly distributed to the other nodes, so that your cluster is again balanced. Once you take out that node from the cluster, it works as a plain normal CentOS box, right? So this is all about your cluster sizing and what type of hardware in the sense in terms of your CPU. What is the configuration that you use here in terms of the CPU? In terms of the CPU, what is the configuration? 2 to 2.5 gigahertz and multi-core CPUs and multi-processors on the same motherboard. So on the same motherboard, you may be having two CPUs and each has got multi-cores. This may have 2 to 4 cores, and this processor also will have 2 to 4 cores. So this is one processor. On the motherboard, you will be having the provision for multiple processors. So this is one physical processor and this is one more physical processor. And in each processor, we have multiple cores, like what been shown here. And each processor has got this much capacity. Same like memory, 16 to 64 GB RAM I'm talking here, depending on, I'm talking about the nodes, data nodes. Network, gigabit Ethernet. Why gigabit Ethernet? Why gigabit Ethernet, friends? Why
So
you need
it should work.
Yeah.
I mean, normal means it won't, data transfer will be less.
Ah, very good.
That's the reason we need.
Absolutely, because I've already shown you. I don't know whether you have gone through that or not. See, when the MapReduce job is getting executed, why we are coming to the MapReduce job again? Even when you are working with your Hive or Pig or anything, ultimately they drill down to the MapReduce job. When the MapReduce job is getting executed, so it gets executed in the phases: map phase, and then combiner phase, and the partitioner phase, shuffle sort phase, then finally reduce phase. When it is going to work in multiple phases, data from one node need to be transferred to the other node. That requirement arises. If data transfer is consuming more time, then the job execution time increases, thereby the efficiency comes down. So to make the data transfer efficient, we require a higher order Ethernet cards. Then only it is possible to have a better transfer rates, data transfer rates. Hope this is clear, friends. Now, you have any questions on what we discussed till now? Nee, Mani, Anne? Anna, you are there?
No, Srini. No, Srini.
Okay. Anna, you are there?
Yeah, I'm here.
Yeah, you have any questions to me on what we discussed today? I mean, till now?
No, I'm good.
Okay.
No questions.
Okay. So this is all related to your sizing, your configuration and all. Now, though it is not the responsibility of an admin, but we need to understand the Hadoop MapReduce job execution. And you need not worry if you don't know how to run a MapReduce job, also leave it. But I'm making you to understand. If you're able to follow it. Otherwise, leave that one. We don't need that. But to understand the performance aspects, you may ask me one thing, Srinivas, why you are talking only about performance related to MapReduce? I'm talking only in the context of MapReduce for the reason. Let me run a MapReduce job for you and show it to you. Then I'm going to show you the performance aspects that needs to be taken into consideration to make your cluster more efficient. So let me run a MapReduce job. Work/MapRed. Hadoop zar. Then I have something called mrjobs.zar. This is my own zar file, and in that simple word count, and I'm planning to sandbox/mary/tmp/sandbox/mary_out. Have a look at this one. If any problem during execution, it is going to show you very clearly. Of course, as an admin, you will not be doing this. You will not be doing this at all. So you need not know. But we are learning for the reason. Now, if this is being thrown, the developer has submitted, and the job got failed. And the job got failed, immediately rush and saying, no, jobs
The
are
file
not
already.
running on the cluster. The jobs are not running on the cluster. That is the usual tendency, friends. Anytime you see, I don't go deeper into my aspects and I don't debug. I just bluntly throw it on the admin saying the cluster is not in a state to accept the jobs and make the jobs to run on it. That is what the comment usually makes. Then what do you do? By looking at the problem what they are sharing with you, you should be able to tell, right? This is not related, this is nothing to do with the administration. This is all the problem with your job configuration or the problem with your coding or whatever it is, but not related to the administration. You understand what I'm saying, friends?
Yes.
Now I submitted my job here. I got Hadoop ZAR. I've given my ZAR file. I've already explained you just before how I actually run my job. You can see that one here. Hadoop ZAR, and you are going to specify where your ZAR file is located. In that ZAR file, what is the job you want to run and where your data exists. That needs, because the purpose of submitting your job is to process the data. So where your data set is located on the cluster, that you need to specify. And then when your job is going to process your data, it produces some output. Where that output need to be preserved is your output path. So every part of this statement has a sense. Hadoop ZAR file. In that ZAR file, what is the job? And when job is running, where it should read the data. When the job produces the output, where it needs to be stored. Everything has got meaning here. And you need not by heart this one to run. Now, it is saying output directory already exists. What is the problem? If the output directory already exists, what is the problem? If the output
It
directory
is not
already
able
exists,
to.
yeah.
It is not able to overwrite the file.
Oh, which is very clear. By default, every job that you submit to the cluster will not override the data if it is already present. Now with this problem, if they come to you saying that, my job is not running properly on the cluster, is it your headache or is the headache of the developer to ensure that the output directory should not exist? Tell me whose headache that is.
Developer.
Developer needs to take care. You cannot bluntly say that job is not getting executed, because by default on the Hadoop cluster, if the path already exists, that will not be overridden by your jobs, because that directory might have been might be storing the output produced from some other job. If you override that output, my stakeholders may be impacted. My stakeholders may be impacted. I mean, if that is a path used by my analyst team to analyze some data, in the same folder I keep one more data now, they start using or consuming that data for their own analysis, things will go to dogs, right? So we need to make sure on the Hadoop cluster, overriding of the existing directories by your jobs is being disabled. That is why when you submit the job, it is going to say that output directory already exists. So I must give out to. Then you see what is going to happen. It creates a new directory now because out to doesn't exist. If it does not exist, then it is happy to create, no problem for that. But if it exists, it will not override. You know theoretically now and practically now why it is not going to override. Now you see here, connecting to resource manager, total input paths to process one, submitting the jobs. You all see this one here, friends. You will be able to understand. There is one more thing called Hue browser here. The Hue browser is actually the browser with which all your roles and services can be well accessed. Your file system can be accessed, your jobs can be accessed, your pig, hive, scoop and all these services can be accessed. Now I think you see here, friends, in the managed jobs category, you are seeing very clearly here what is a job that is being submitted. Now the simple word count job is being submitted, it is running, and the percentage of maps that is getting executed and the percentage of reduces that is getting executed. You see that one very clearly. The status is running. If something goes wrong, then you are going to see that this got stopped for this reason. You can go and debug. Of course, this is all the headache or the responsibility of the developer. But we are seeing this for the reason I want to show it to you clearly. Unlike your traditional programming execution, your MapReduce job executes in multiple phases. You have a map phase, You have a combiner phase, partitioner phase, shuffle sort phase. You see here it succeeded. You go and see this one into the deeper details. You'll be seeing what are the tasks that got executed. There is a map task. I think you see underscore M, that is a map type task, and underscore R, that is a reduce type task. So you see, when the map phase is going to finish the execution, it produces some output. Where that output needs to be stored? Because I need to preserve the output of the map till it is consumed by the reduce, and reduce is going to finally produce the output. So this life cycle you need to be clear, because of the reason I've shown you very clearly the ecosystem sometime back, friends. At the very lowest level, we have something called storage. On the top of storage, you have something called processing. And on the top of the processing, you have something called access. And on the top of the access, we have something called management. And on the top of management, we have something called data analytics. This all is surrounding the concept of data only. Data storage, data processing, data access, data management, and data analytics. Now at your storage level, we have only something called HDFS. At the processing level, we have something called MapRed. And access level, we have Pig, we have Hive, we have Scoop, all these things at your access level. You write a Pig script and you run that one, it run as a MapReduce job. Because you write a Pig script and you run that one, your Pig script will get converted into a MapReduce job and run as a MapReduce job. You write a Hive query, and run that one, it gets converted as a MapReduce job and runs as a MapReduce job. So ultimately, let you have anything at the data access level, they must be converted into MapReduce job and should run as a MapReduce job on the cluster. So on your Hadoop cluster, we have only one processing technique called MapReduce, directly and indirectly, Pig, Hive, Scoop, and all. So if you look at this one very closely, you understand. If you look at this one very closely, you understand that this part, whatever the MapReduce job that is running for you, if this MapReduce job needs to run efficiently, then we need to have, look at this one closely, friends. This is very, very crucial and very, very important for our discussion, for the reason, without this you will not be able to understand much. Without understanding the MapReduce, you will not be able to understand anything in the entire Hadoop cluster. This is very, very crucial. Look at this life cycle of the MapReduce job. You will be able to understand things at a different level. See this one, friends. We have a map phase. So on node 1, you see that on node 1, we have 3 maps running because we have 3 blocks. You imagine, friends, split is nothing but a block kind of thing. I mean, it is not exactly block, but split and block are the same. I use the term called split in the processing part. I use the block in terms of my storage. When I talk in terms of storage, I use the term called block. Same block when I come to the processing, split. There is a small difference between split and block in terms of the records present inside your block. So let us not go into those details. So your block is going to be processed by one mapper. Suppose for any given file, this is a very important point and very important thing that needs to be understood by you, friends. Suppose you want to process a file called abc.txt and this size is 1 GB And 1 GB is uniformly divided into how many blocks? If it is 128 MB into 8 blocks we get. If the file is, if the block size is 128 MB configured at your cluster, your 1 GB file is uniformly divided into 128 MB blocks, and those will be 8 in number. I hope you are following with me what I'm sharing, friends. So 8 blocks will be there. These 8 blocks are present on different nodes. Imagine out of these 8 blocks, 3 are present on my node 1, and the other 3 are present on my node 2, and my last 2 are present on node 5. So I have 3 blocks present here. I have 3 blocks present here, and I have 3 more blocks present here, and I have my 3 more blocks present, 2 more blocks present here. Now, each block is processed by one mapper. Now, when this block is processed by one mapper, it produces some output. This also produces some output, and this also produces some output. Now, this produces some output, this produces some output. So these are called partial outputs. Now all these partial outputs need to be finally made into one output. That is the reason why your MapReduce job execution happens in phased manner, not in one single step like how it happens with your traditional programming. So we have a mapper phase, and after mapper phase we have something called combiner, and after combiner we have something called partitioner, and after partitioner we have something called shuffle and sort, and finally we have something called reducer phase. Mapper is going to read the data from HDFS, and reducer is going to write the data to HDFS. There is no ambiguity. In between, the data is stored on the local file system. That is the reason why, friends, I'm saying here, I don't know whether, maybe the point is very small, but 25% I need to reserve it for my MapReduce is for the reason, don't think that on the cluster only one MapReduce job will be running at any point of time. There will be multiple MapReduce jobs running on the same cluster at the same point of time. I think you noticed here, each night we run 112 jobs. When they're running 112 Hadoop jobs each night, you think your Hadoop jobs are going to run one after the other?
Yeah,
No,
it's like
Srinivas,
parallel.
parallel.
At any point of time, there will be multiple MapReduce jobs, multiple Hadoop jobs. Let us not call MapReduce. Honestly, we need to call as MapReduce only, because even you work with Pig or Hive, they ultimately work as a MapReduce job only. So I call MapReduce directly or indirectly. So when we have multiple MapReduce jobs running, then definitely I think you understand and agree with me, friends, why I need 25% of the storage capacity is reserved for your intermediate MapReduce data storage. You got the point? Look at this diagram very closely. You understand, when map is producing some output, the intermediate key value pairs need to be stored somewhere. You see here, your data is being read from HDFS, and ultimately data is written to HDFS. But in between, your combiner phase, your partitioner phase, your shuffle sort phase, all these, your data is being stored locally. When your data is being stored locally, you definitely need to reserve some space for that also. I cannot use the entire hard drive. I cannot use the entire hard drive for my distributed file system. A part of the hard drive I need to use for this one. And I also can clearly tell you, when your hard disk is getting filled completely, then the performance starts coming down. Keeping that thing in the mind, I need to give some more room for that one. Keep all these things. 1/3 of your hard drive is left. 25% for your MapReduce temporary storage. I already mentioned here. What is that? Hope you understand. That is the reason why 25 to 33% of the space I need to keep it reserved. Then only I'll be able to keep up my performance. Hope you are clear with this one, friends. What I'm trying to share. Now thing is, look at this one. It is trying to run. It is trying to run the MapReduce. It is trying to run the MapReduce jobs. Each block is processed by one MapReduce job. I said. I mean one task. So let it be any task on the cluster. It is all. Let it be any task on the cluster. You need to understand this point very clearly, friends. Here, let it be any task. Any task on the cluster, it works inside the JVM. This is what the JVM, and your task going to run inside this one. This task is going to process. This is a split, or I call this as a block. This block is processed by the task, runs under the task tracker, runs under the job tracker. Job tracker takes care of task trackers. Task tracker takes care of tasks, because for each node there will be only one task tracker. Under each node there will be one more JVM now and one more task running, and that takes care of processing one more block. This is split. Now imagine, friends, this is the most important thing. Imagine that on a particular node I have 20 blocks for a given file. You think is possible that 20 blocks will be processed in parallel with 20 JVMs? Can I spawn 20 JVMs on the machine, friends? Is it possible? Is it possible to spawn 20 JVMs?
Yes.
Yes, if I have enough resources. Enough resources, I mean memory and CPU. Because each JVM requires its own memory and its own CPU. Because this is a process basically. Each process requires its own memory and CPU. If I need to process 20 blocks present on a single node, if I need to spawn 20 JVMs, I need to see whether my node has got the ability to give the memory for 20 JVMs in terms of the processing or not. If not, what happens? Maybe 10 blocks been processed with the help of 10 JVMs. Now, you know very well, I am not sure whether you have some programming knowledge or not, but if you look closely here, friends, that's not a problem. Bear with me for a minute, friends. So I compiled my demo.java file and I'm trying to run that one. Now I got the output. This is very clear. But the fact that you need to learn or understand here is Java, verbose, and I said demo, you will come to know clearly you'll come to know clearly here, when your JVM is getting started, when your JVM is getting started, you see that lot of, I think you see here, it is loading and all it is saying. And finally, your actual class is being loaded. What is actual class here? What is actual class here? The actual class is your demo class. That is one that needs to be loaded. Loaded your demo class. After loading the demo class, your hello world is the output that you got here. And finally, what is happening? Shutdown is happening. Please observe this carefully, friends. Your JVM is getting shut down. Your JVM is getting shut down. When your JVM is getting shut down, you understand from this one, there is a startup also available for the JVM. You have a startup and you have a shutdown. So it is working like your operating system only. It gets on and runs the process inside, and when you don't need, you are going to shut down that. Same like even your virtual machine is also working. It has got a startup process and a shutdown process. Now, if I need to process 10 more blocks, I need 10 more JVMs again. Every JVM startup will be there and shutdown will be there. If I am able to reuse the same JVMs which are started before, I'll be able to definitely consume time, right? Are you able to understand this one, friends?
Yes, Srinivas.
I want you to understand this point, friend. This is the most crucial thing. See, that is where I always prefer to give the right basics, because you go to the workplace and you are being asked to fine tune your cluster, and with some metrics you did, if someone asks why you made this one, you say that it is as per the documentation, it sounds ridiculous. You need to have the technical strength to understand and identify how you need to configure. Suppose if the same JVM, friends, here observe, 10 blocks are processed using 10 JVMs. Instead of those JVMs getting shut down, if the same JVMs can be reused by the task tracker to process the next set of 10 blocks, my JVM startup times are being saved, and thereby the performance of the job increases. How I am going to tell reuse the JVM? Are you getting my point here, friends? If my started JVMs are able to be reused, then I'll be able to save my time, because I have shown you very clearly here. For that sake only, I have taken pain to write a small Java program and run it and show it to you. There is a shutdown of your JVM, which you see here last. Obviously, when there is a shutdown, there is also startup. Whatever you are seeing here, all this loaded is what we technically call it to be startup only. When JVM startup is been avoided, because ultimately what is running inside the JVM? Same job is running inside the JVM. For that sake, why the JVM need to start once again? That is the reason why we have an option at your Hadoop cluster level. Reuse the same JVM. Reuse the same JVM. If you are able to reuse the same JVM, then I'll be able to save the time, thereby the performance of the job increases. Now tell me, if I just say there is an option called reuse JVM, enable it, then your performance increases. You never come to know why that is being done. That is the reason why I am compelled to discuss these aspects. Which aspects? The concept of your MapReduce, and what is the life cycle of the MapReduce, and why the concept of reusing the JVM arises in terms of the cluster. Now, when you enable the reuse of the same JVMs on the cluster, then in terms of the job, not the cluster, we will not be saying at the cluster level. When you are submitting the job, if you are able to I mean, not every time you do that one. You are going to set up the configuration parameter saying that the same JVMs can be reused so that the performance of the job can be increased. It makes sense, friends?
Yes, Srinivas.
Is that clear, Anay? Yeah, Mani.
Yeah, Srini, yeah.
Yeah, it's clear.
So you need to make sure that that these aspects, that is where I'm saying here, yes, you can see that one here. Look at this aspect, you'll be able to understand. See here, mapred.child.java.opts. I'll be showing that one, don't worry. Where this is available, this property is available as part, of course, you can do these configurations even from your /user/lib/hadoop, and there you have something called conf, and you see here mapred-site.xml. You'll be seeing here, see here, friends, look at these properties. I don't know whether you are looking at these properties properly or not. Let me show you that one. Yes, all these properties are going to influence the execution of your MapReduce job. Yes, let me show you. MapReduce.map.output.compress. MapReduce.map.output.compress. What do you understand from this property? And that is being kept as true here. How it is going to influence, friends? How it is going to influence the performance of your cluster? How this property is going to influence the performance of your cluster?
So
Because
output.
in the interview you are going to be asked this one. Tell me some of the performance tuning factors that you came across and how they are going to influence. Then you cannot say, because performance of the cluster is directly or indirectly nothing but MapReduce only. Other memory aspects and all which I have described before, 25% needs to be left for your MapReduce, that is for your temporary storage of the output produced by the MapReduce job. That is all a different thing. But when it comes to the performance tuning of your cluster, it is directly or indirectly with your MapReduce only, nothing more than that. Tell me, yeah.
So the output file size is compressed instead of loading the output into full.
Which
It is
output?
kind of zip.
No, which output? Which
Your
output?
MapReduce, map output.
Yeah, not MapReduce, map out, because the reduced output is finally written to the HDFS only. That we decide, that is the decision factor of the programmer. Programmer will decide, developer will decide whether the output of the reduce need to be stored in the compressed form at the cluster level or not. But in terms of the MapReduce job execution process, if the output of the map is being kept in the compressed form, if it is being written, if a small amount of data is written to the hard disk, I will read a small amount of data, then obviously the performance increases. You know very well, majority of the time is spent in reading or writing, I mean IO activity, than processing activity. I don't know whether you are aware of this or not, friends. The major bottleneck is in terms of IO, not in terms of processing, because the processor processing capability is very high compared to the reading or writing. The level at which we process the data, at the same level we cannot do IO activity. If we do the IO activity at that level, the hard drives will get burnt. If your read-write arm is going to move at that speed, your hard drive is going to get burnt. The rate at which the processor is capable of processing the data, at the same rate you cannot read or write the data. If you do with the existing hardware structure, that is the reason why we are moving away from hard disk drives to solid state memories, flash memories, where you will not be having this read write arms there. And wherever these read write arms are there, the friction arises, and if you move the read write arm beyond some speed, it generates sparks, and thereby, it produces heat basically, and that's going to burn the hard drive. That is the reason why we cannot make the read write arms move beyond some speed. That is the reason why if you are able to write a small amount of data, instead of me writing 100 MB of normal data, if I am writing 50 MB of compressed data, my writing is going to be faster. Obviously, that the output needs to be read by my next phase again. My reading is going to be faster. Of course, data is the same data, but instead of storing in the normal format, if I store it in the compressed format, my efficiency is going to be more. I hope you are following with me what I'm trying to share here, friends. That is the reason why MapReduce.map.output.compress, if I make it true, then what happens? My writing and reading is going to be faster, thereby my MapReduce job execution is going to be much faster. And you also see here MapReduce.map.sort.spill% is being kept as 0.8%. 0.8% nothing but 80%. There is a spill buffer available with your MapReduce job. When 80% of that buffer is being filled, then only it is written to the local file system. Till there, it is been preserved in the memory. If this factor is kept very low, the performance is impacted. Kept 0.99, then also it is been impacted. And you also see here MapReduce.task.timeout. What is a timeout? Till then it is going to try running your MapReduce task. Beyond that one, it is going to complain. Yes, it is not happening anymore. MapReduce job .reduce as default number is 1. And MapReduce.task.io.sort MB. I've already mentioned here, friends, very clearly. There is a shuffle and sort phase. Now, how much amount of memory needs to be used during your shuffle and sort phase, that is being fixed by you here. If this is more, then because this being a pseudo cluster, it is being kept at 16 MB. It can be kept more. This is a factor which is going to be MapReduce.map.speculative is false. MapReduce.reduce.speculative is false. If this is being kept as true, now, are you following with me, friends? It looks that these are developer aspects,
Yes,
but these are not developer aspects, friends. Sunil, I think you remember when you have gone through the developer program, we didn't discuss all these things. You remember?
Yes, Srinivas.
Because all these things are directly related to the developer, but usually been taken care by the administrator, so that the performance of your cluster is being drastically improved. Now tell me, friends, how these factors can be understood by you. If you don't know what is a map phase, if you don't know what is a reduce phase, I just enabling or disabling, someone said enable it improves the performance, you don't know why, then you'll be doing it, but you never come to know why you're doing that. The reason behind, I tell you now, here if you see closely, if some part of the MapReduce, see here, there are multiple map tasks running for you in the background. Suppose if you see the map task, if a particular map task is taking more time, there are 5 map tasks that are running on your cluster. Only when all these 5 map tasks are going to finish, then it goes to the next phase. Till the map tasks are going to finish, I will not be going to the next phase. Now imagine, out of these 5 map tasks, 4 got executed and got completed. It is waiting for the fifth map task to be completed, then only it can go to the next phase. If this fifth map task is taking too much time, whatever the reason, you know very well, all these blocks are available in the replicated factor also in the other nodes. Same block is available 2 more times on the cluster. What the cluster will do is, what your job tracker will do is, it will identify the other 2 blocks, the replicated blocks of the same block on the cluster. It will start initiating the task to be executed on those replicated blocks also. Out of these 3, which is going to finish fast, that output is being taken into consideration. Remaining 2 tasks are going to be discarded. This kind of execution is what we call it to be speculative execution. Are you able to understand this point, friends? MapReduce.map.speculative is false by default here. But when this being a pseudo cluster, that is not possible. That is the reason why we made it as false. But on a production cluster, we keep this value to be true because it improves the efficiency of your MapReduce job. How it is improving the efficiency of the MapReduce job? How it is going to improve the efficiency of the MapReduce job? Because if some task is taking more time, then immediately it decides, oh, let me initiate the same task on the replicated blocks. Whichever is going to finish fast, that output is being taken into consideration. Remaining tasks are being discarded. Thereby, I'll be able to finish my map phase early and go to the next phase comfortably. Now tell me, friends, whether this factor is going to influence the performance of your MapReduce job or not.
Yeah, it improves the performance.
That is where we need to understand the aspects that are connected to your performance aspect. So I think we have discussed too many aspects here in the today's discussion. You also see MapReduce.max attempts. How many maximum attempts it need to attempt before it declares that this task cannot be executed. Can also be decided by you. Too many is not good. That is where we by default keep it as 2. 2 to 3 is okay. Beyond that is not, because it keep on attempting the same task to be executed again and again. Then it is going to impact your job execution. Let it die, let it get killed, and we restart the MapReduce execution once again. And that makes your, maybe second time when you run, you are going to take few more factors into consideration before you submit the job. Then your job is going to run smooth. So this gives you a clear understanding. There are parameters that influence the performance of your MapReduce job execution. That is nothing but your cluster performance. Make sense, friends? So I'm going to share, don't worry, I'm going to share the details about the performance tuning factors and the impact of those factors and how they need to be configured to make your job executed successfully. Make sense?
Yes, Srinivas.
Good.
Yeah. Yes, sir.
So you have any questions to me on what we discussed in the today's class about sizing, the hardware configuration, and the planning of the cluster and the performance? Performance tuning is not at war. I only introduced performance tuning today. We are going to discuss this one time to time because we will not be able to see every aspect of performance tuning in one single shot, because this is also connected to the other concepts of your Hadoop administration, not just with your MapReduce alone. That is the reason why performance tuning aspect is going to be discussed time to time. Over a period of time, you will have understanding, oh, all these are the things that are connected to the performance tuning, which I need to take into consideration while making my jobs to get executed, more efficiently on my cluster, and the other factors apart from the MapReduce fine tuning. Make sense, Anne? You have any questions to me?
Yeah.
Yeah.
No, I'm good. Thank you.
Yeah. So you have, please go through the things, whatever we are discussing, and You have any questions, Anna, please don't hesitate to share. There is a reason why, we discuss certain things which are not directly connected to the administration. You may think that at this stage these may not be required, but when you start progressing, you will be seeing there is a considerable impact. That is the reason why file system is being discussed very in detail. Linux file system also been discussed very in detail. So we feel sometimes they are not connected directly to your administration, but they play a vital role in terms of understanding certain aspects. So you feel that certain things you are not able to digest, please don't hesitate to share with us so that we'll be discussing those things at the end of the session, or as a separate session. That will not be a problem at all, right? Because
Okay. Yeah, that's fine.
as we know clearly that what your future concepts are going to be and how your existing learning is going to impact your future learning. So we discuss certain aspects well in advance so that your future learning process will not be impacted, right? So wonderful, friends. If you don't have any questions for today, we wind up at this level. I'd love to see you back in the next session, but make sure that before you come for the next session, you do some homework on sizing, configuration, hardware configuration, and the performance tuning aspects. I try to keep some content on the blog, as been requested by me. I think someone requested to put this MapReduce PPT also. Money, I think you mentioned, right? So I'll definitely do that one. I'll place these things on the blog so that you can access them and go through them. You have any questions?
Yeah, sure. Thanks.
Those things.
Thanks.
Yeah.